Okay, drawing, 3D modeling. So we're looking at our exercise 3 here. We finished exercise 1 and 2. I won't go through your exercise 2 in a moment. Let's just jump straight into our 3D modeling. So far, what you've been drawing has been 2D. Yeah, so you've been drawing everything X and Y. Now you draw your exercises, okay, you'll be drawing X and Y. So this is got its own coordinates, this has got its own coordinates, so on and so forth. Yeah, so X and Y. How do we go from 2D over here? How do we go from 2D to 3D? It's really simple. All we do is from XY, we add another dimension, which is the Z direction. So right away, just by adding one dimension from 2D, we go to 3D. So that's how we do it. Yeah, that's how we go 2D to 3D. We're just gonna go X and Y. We draw X and Y first, then we add a Z direction. So if you were to draw a cube, you would draw a square first, and then you add the Z direction. If you wanted to draw a cylinder, then you would draw the circle. Draw a circle, and then that's the area. So that's pi square, whatever that is. That's got the circumference and everything with a radius and everything. And then you would have a Z direction. Then you have a cylinder. So everything you see, you know, we've been doing some Inventor exercises previously. Everything you see is just made up of primitive shapes like this. Got circles and squares, curves, arcs, anything like that. Okay, they all just chantom together to make your X and Y, your sketch. You add a Z direction, and suddenly you've got a 3D model. So let's look at this example here. One thing that you'll need to practice is breaking things into individual parts. When you see an object, what do you see? In this case here, I can see a few things going on. I see that there is a base. So there's a base over here. It's got a width, then it's got a depth, and then it's got a height. So that's got a height over there. So that I see this base first. After I see this base, I see another wall over here. Okay, I see that wall. That wall it will be easiest to draw this wall straight up as a square like this. So there's a wall over there. And then after I see that wall, I see that this part is curved. So there will be a fillet. I will add a fillet over here. After I add the fillet, I see that there's a hole over here, so I would have to make a circle somewhere and then tell AutoCAD wherever that circle is touching later, I want you to cut off that region. Actually, it would be best to flip it around, to do the cut first and then fillet. But actually, for a simple component like this, it doesn't really matter. So let's keep it at that lah. Just know that sometimes for different components, especially the more complicated ones, it does make sense to decide whether to draw the circle first and then fillet, or fillet then draw the circle, things like this. So just be aware that there are considerations like that. Again, for us, don't have to worry too much. So we've got those few things there. Let's do that in Inventor. Inventor, really simple. You see this landing page, we're going to make a part first. So let's click on part. Before we do that, you might want to make sure that under the templates, you click on the settings, make sure that the measurement units is in millimeters. Drawing standard, anything is fine. So if yours is in inches, switch to millimeters, that's okay. Then go into part. If for some reason you missed that thing, or maybe you've got a previous installation and this is in inches, no problem. We can go to tools, click on document settings. Under units, we switch length to millimeter. So that's millimeter, that's fine. Now let's start drawing. Remember, we're going to start with our X and Y. That one is the sketch. So we're going to sketch in X and Y first, and then we're going to go to 3D model to add the Z direction. And you can see there are many ways to add the Z direction. We go through them one by one. So sketch, let's start with a rectangle. We want to draw this base here first. Remember, this base over here. So to draw that base, there's going to be a rectangle of 50 by 55. So let's draw that rectangle of 50 by 55. Let's say it's here. So I choose that plane to draw on. I'm going to choose a rectangle. Anywhere is good. And then we've got our rectangle. It's slightly different from AutoCAD. In AutoCAD, we predetermine where the dimension is going to be. We have to be very careful. We add the dimensions in as we draw. When we draw a line, we give the direction and the distance and all that. For Inventor, it's easier to have the basic shape out first, and then we go to dimension and give it the dimensions that we need. In this case here, this one would be 55. Let's zoom out a little bit, and then this one will be 50. After that, we want to make sure that this rectangle sits on the origin. Let's call it the origin. And there are many ways to deal with it. I won't go through all the different possibilities. Just try as much as possible to either center it. So let's have an example of centering. Let's say if this thing here is 50, I want the center to be in line with the origin, which is this origin here. So since it's 50, the middle will be 25. So I'll click this line, and I'll click this dot, and I'll tell Inventor that I want you to put this in the center. 25. And if, for example, I wanted to center this square directly, I would say here and here. This distance here will be 55 divided by 2. Very convenient. Don't have to use a calculator to divide it first. We can just key in the calculation into the dimension. So in case you're wondering how to do that, you just have to double click that dimension and you can make those changes. Alright, so what I've done there is I've put 0, not a very elegant way of doing it, there are better ways to do it, but I've placed this rectangle sitting on our base plane, and then I want it to sit like this for whatever reason. Sometimes you want to center, sometimes you want to sit against something else. It's fine. So I've got my rectangle, I've got my X and Y. Now I want to give it the Z. So the Z direction, I will go to 3D model, click on extrude, and then I can give it whatever thickness is supposed to be, which is 8. And now we have our base. So we've got this bottom part here. Now we need to add this portion. So let's add it. We know that it's going to start somewhere around here, and then it's got a thickness of whatever this distance is, which is 55 minus 47. This is the dimension given to us like this. So let's do that. 55. Now let's start 2D sketch. On this plane, we start a rectangle. What I'm doing here is I'm drawing the rectangle, and I've told Inventor that I want this point to be on this line here and the next point to be here. So this means whatever width this one is going to be, if next time I want to change it, this rectangle is also going to follow. So that's one of the powers of constraints. By relating one line to the next line, we're able to make the drawing update automatically. Then we need to add a dimension for this thickness. So this one would be, I know it's 8, but let's just try 55 minus 47. So that's 8. Finish the sketch, give it an extrude. This time the height is 60, the whole thing is 60, 16 minus 8. So the height is 52. Alright, so that's our height here. You can see straight away we've got the basic shape already. All we need to do is cut a hole and then add the fillets. Let's do that now. Let's make the hole. We're going to create a new sketch of this area here. And I know the circle is going to be in the center. But where is the center going to be? And just like we did in AutoCAD, the easiest way is to draw a couple of lines as a reference and then add some dimensions. So I'm using this midpoint here. Just like AutoCAD, we've got a midpoint snap. I'm going to snap it down to here. And then I'm going to do something special. I'm going to right click on the line and I'm going to select construction. What this does is it will use the line as a construction. It will be there for measuring and for referencing and everything, but when it comes to extruding, it won't exist. Yeah, this will be XY, but you won't be able to add a Z to it. So construction line there is purely for reference. Now we've got this point here, we can just add a circle at the reference point, and we know that the diameter is 25. Now we've missed out something. We've got the center point, we've got the diameter, but what about the height? You don't know what the height is. So what we need to do is we need to add a dimension here to here. We know that that height is going to be 35. Let's click 35. And then we have our circle. We finish the sketch. We click extrude. And you can see this time, instead of creating material, we want to cut away material. So you can see here on the output, the boolean is either a join, a cut, or an intersect. Most of the time it's just join or cut. We don't want to join, we don't want to create this feature, we are going to cut instead. And Inventor very helpfully realizes that if we are going to cut, we have to cut something, so we flip the direction towards the other side. And then whatever that feature touches, it's going to remove. It's not very good practice to have something that's sticking out like this. In future, you might have other things there, and then you might cut the thing instead. So we can use something like to next. You can play around with it. But to next here, Inventor has decided that we want to cut from this plane to this plane, and so it's managed to do that. If you're happy with the cut, click OK. Now we have the cut. Last thing to do is to add the fillet. Just gonna add this fillet to this edge and to this edge. The fillet size is 25. If you're happy with that, click OK, and we have finished our 3D model.